Yes, it's calculation time with Dr. Dave. And this lesson, we're going to be talking about reconstitution of powders that are for sterile. And they are identical to the types of calculations that you do when we're dealing with a powder for reconstitution that's going to be given orally. Just the way in which we do it is a little bit different, but the concept is exactly the same, and the math is fairly the same in what we're doing. It still is a powder that's being reconstituted with water or some other diluent. So whenever we do this, we have to understand one common thing, which is the same, like I said, even when we do it with the oral products, is that the powder will typically dissolve in the liquid. Sometimes it doesn't dissolve if it's a suspension, but if it dissolves, it may take up space. And that space that the drug powder takes up has to be accounted for, right, in the final volume of the reconstituted solution. So the manufacturer takes that into consideration. So let me give you an example here. It says on a vial of an antibiotic powder, so the vial itself will give you this information. The vial states that to produce a 10 mLs, right? So here's what I'm going to draw. So we have a drug vial. Very bad at drawing vials, but let's say this is a drug vial. The drug vial says it's a powder. So that means I've got a bunch of powder sitting in the bottom here, right? Just powder. It says that if you want to produce 10 mLs, so if I wanted to get 10 mLs, right, and you want the concentration of that 10 mLs to be 10 milligrams per ml, right, it says that you would reconstitute it with 7 mLs of sterile water. So I'm going to put here 7 mLs of sterile water. So 7 mLs of water is going to go into the vial. The space that 7 mLs of water takes up is 7 mLs. The space that the powder takes up is accounted for. That's what's going to bring us to the 10 ml mark. So 7 mLs plus the powder, right, that's in the vial is going to equal 10 mLs. That's what it tells us. So the question is, well, what's the volume that the powder is occupying? So how much volume is this powder occupying when it's dissolved? Well, we know that 10 mLs, right, is what we have in the end. We know that 7 mLs is from, I'll call it the water. So 3 mLs of volume is going to be from the powder. That's it. So the powder takes up a space of 3 mLs. All right. All right. We can also get a little fancy with these. And let's say that then the problem that you have is that you've got a solution when you put 7 mLs in there that's 10 milligrams per ml. But let's say that was too strong for the purposes of what the product was being used for. And a physician asks, can you dilute that down so that there's 4 milligrams per ml? And your answer would be, of course I can. And then you go back and you sit there and you're like, oh, how am I going to do that? You know there's a way. How do you figure it out? Well, I'll do it a few different ways. Thought-wise is that you know that there's 10 milligrams per ml, and you've got 10 mLs. So there's 10 milligrams per ml is what the final concentration is. Well, how much drug is inside of there? How much drug is inside of this vial? Well, you know that there's 10 milligrams per ml, right? Because that's what the final concentration was. And you know that the final mLs was 10. So you know that there is 100 milligrams of drug. 100 milligrams of drug is in this vial. If you know that there's 100 milligrams of drug in the vial, and you want 4 milligrams per ml, that means that every 1 ml is going to be 4 milligrams. Well, if you got 100 milligrams, right, that's going to be your 25 mLs. So you know that this vial that you're now going to make is not going to be 10 mLs. You need to go all the way up here to 25 mLs. If you have a volume in the end, which is 25 mLs, you will get your 4 milligrams per ml. The only problem is that we can't just add 25 mLs of water. We have to account for this drug down here. This drug took up 3 mLs of space. So 25 mLs minus the 3 mLs, which is from the powder, right, will give us the amount of water that we need to reconstitute this with, which is the 22 mLs. This is how much water we're going to do. That's walking you through it. If you want to, you can also use your C1V1 equals C2V2. Why? Because I have a concentration and I have a volume that I want, right? And I have another concentration and I have another volume that I'm looking for. So concentration 1 is 4 milligrams, right, per ml. The volume that we have is 10 mLs, right? And we want that to also be equal to concentration 2, which is we want this to be, oh, I apologize. This is what we want. Sorry. This is 10 milligrams per ml, and we have 10 mLs of it. I want 4 milligrams per ml, and I've got X mLs. We don't know what we need. We have X mLs here. If you do that same way out, you will come up with 25 mLs for X, but you need to subtract the 3 mLs for the powder, and that'll leave you again with the 22 mLs. So either way you want to do it, or makes you feel comfortable. All right. Next one to look at. Now you have an antibiotic, ceftazidime powder, and it states that for a 280 milligram per ml concentration, so this is a powder for reconstitution, so it's powder for injection. You know already it has to be diluted. You can't just inject the powder, it has to be diluted. So this is a vial powder, the antibiotic. It's a 1 gram vial. So here's my lovely picture of a vial. I've got some drug down on the bottom. This drug. I've got how much drug? There's 1 gram of powder, 1 gram of drug, I should say. There could be more powder, but 1 gram of drug is there. And it says that if you want to get a 280 milligram per ml solution, right, you would add 3 mLs of water. So we're going to add 3 mLs of H2O. The question says is what is the final volume of the solution? And how many mLs should be withdrawn from the vial to obtain 500 milligrams of ceftazidime? Well, we know that when we add 3 mLs into here, right, we're going to get a 280 milligram per ml concentration. The question is saying, well, how much of this drug powder took up in terms of volume? So we just start with what we know. We know that in every 1 ml, right, it's 280 milligrams, right? That's what we know right here. It's also saying that we got 1 gram of drug inside of there. We got 1 gram of drug inside of there. 1 gram is 1,000 milligrams. So, of drug. So what's happening here? I am saying that every 1 ml of this solution, that we don't know what the final solution is, but every 1 ml of that will have 280 milligrams of drug. Well, if I've got 1,000 milligrams of drug inside of that vial, I should be able to tell you what the final amount of mLs was, which would be 280 divided by that, we've got about 3.57. So 3.57 mLs is what the final, or 3.6 mLs is what the final volume will be on the reconstituted suspension. Now it says, how much of that do you have to withdraw to get your dose of 500 milligrams? This has nothing to do with the reconstitution. This is saying you got 1 ml contains 280 milligrams, right? And you want a 500 milligram dose of the drug. We're going to get that. This is about, let's see, 1 point something. So 500 divided by 280, you get about 1.78. So around 1.78 or approximately 1.8 mLs is what you're going to give. Be mindful that sometimes there's a lot of information that you need, and a lot of times there's a lot of excess information that you don't need. So there's no need for us to know that 3 mLs was added. It has nothing to do with the question. So read the question carefully, understand what it's asking you, and then approach how you're going to solve it. All right. That's it for reconstitution of powders for sterile. As always, calculation is the most important class because you know it's the only one that counts.